Binomial distribution. Now that we have learned about discrete random variables and the probability distribution of discrete random variables and how to define and actually find the mean or the expected value of discrete random variables and the standard deviation and variance of them, we want to learn about certain probability distributions that they are so popular that they actually have the names of their own, because they are very common in nature and in our life, so that statisticians and scientists, they have given them their names, and using them, studying them, we can compute their probability. We can actually find the expected value and the variance and standard deviation of them very easily. So let's start with the first one, which is the binomial distribution. Binomial distribution happens when there are only two possible outcomes for an event, and these two outcomes has to be mutually exclusive and collectively exhaustive. For example, a very popular example that we know of this event is the outcome of tossing a coin, which we either going to get a heads or going to get a tails. It is common to refer to the outcome that we are interested in as success and the one that we are not interested in as failure. For example, if we are tossing a coin and we are interested in getting a heads, then we are going to define the heads as success and the tails as failure. So success and failure here are not are subjective name. They are not inherent into whatever goodness you define as success and bad thing as failure. So it's defined based on the problem. Examples of binomial distribution. The first one, of course, in flipping a coin, which has only two outputs, two mutually exclusive and collectively exhaustive outputs, getting a tails or getting a heads, or anything with a success and failure that doesn't have a tie. For example, when you take a test, you're either going to fail or you're going to pass. So that's going to be an example of binomial distribution. Or shooting a target, you either going to hit the target or you're going to miss the target. So that's another example that a binomial distribution can be applied. Let's now get a little more deeper and dig deeper into binomial distribution and figure out how the formula would work, finding the probability distribution. All right, suppose we have an event that has only two possible outcomes, a success failure outcome. For example, tossing a coin, it only have two outcomes, heads or tails. Whatever you want to define success here, as a tails or a heads. Now, suppose that we repeat this experiment of tossing a coin multiple times, for example, n times. Now we are interested in getting the number of success. For example, suppose heads for us is a success. So we define x as the number of success in this experiment of n with n repetition, okay, which is number of heads that we get. So we could get, if we toss a coin n times, how many success are, what are the possibilities here? So we can have 0 success, right? We can have, that means all of the n times that we toss the coin, all of them becomes tails. Or we can have actually 1 head, 2 heads, 3 heads, and the best scenario, ideal scenario, is that all of the n times that we toss the coin, we're going to get a heads or a success, right? So there are these n plus 1 possibilities, as you see here, n plus 1 possibilities, right? 0, 1, 2 to n plus 1 possibilities. So that's these are the total outcome possible for random variable x, number of success. We want to, for any specific values, we want to find the probability. What is the probability that we get a small x? This is just a value, x number of success. So big X here is the random variable, and a small x here is the value of random variable. For example, I am interested in finding 2 success in my experiment, or in our tossing a coin experiment would be, what is the probability of getting 2 heads? So x here actually is an example of binomial distribution. So we'd say x follows, this means follows. X follows binomial distribution. We show it by bin, and then we show 2 parameters here, n and p. N is the number of experiments that the number of repetition that we do here. For if the example is tossing a coin, it's the number of times that we toss the coin. It's also called the number of trials. P, on the other hand, is the probability of success, meaning that the probability that you get, for example, a heads, if you define heads as a success. So let's now see the formula to computing the probability of x. This is the formula for the probability of getting x number of success. So again, capital X is the variable, the random variable, and a small x is the number of success that we want. Also, P is the probability of success, and n is the number of trials, or the number of times that we repeat the experiment. X is the number of events of interest. We also call it success, right? We can call it success. N is the number of trials, or the number of times that we repeat the experiment. And P is the probability of event of interest, or probability of success. Let's now see an example. Let's going back to the simple example of tossing a coin. Suppose we have a coin, we toss it 4 times. So N here is 4. And we define X as the number of heads we get. So heads is our success for us. The probability of success, or the probability of getting a heads, is 50%, because if the coin is fine, in a fine condition, there is 50% chance that it's going to be a heads, and 50% chance that it's going to be a tails. So the P is the probability of success, or getting a heads, and 1 minus P is the probability of failure, which is getting a tails. In our experiment is the same, 50%. And what are the possible outcomes for random variable X, which is the number of heads? It can be 0 heads, no heads at all, 1 heads, 2 heads, 3 heads, and 4 heads. So now using this formula here, we can actually find the probability of getting of any success. So for example, if you toss a coin 4 times, and the probability of success is 50%, and the probability of failure is 50%, then what is the probability of getting 3 heads? So using this formula, we can actually compute that. Let's see an example. Suppose the probability of purchasing a defective computer is 2%. What is the probability of purchasing 2 defective computers in a group of 10? So here, suppose we are purchasing a computer. Each time that you purchase a computer, there are 2 possibilities, whether the computer is going to be fine or defective, right? There are only 2 possibilities. So this seems to be suitable for a binomial distribution. Okay, so if we define X as the random variable, as the number of defective computers. The number of defective computers, then X actually follows a binomial distribution with N and P. N is the number of times that we purchase a computer, or the number of computers that we purchase. We actually purchased 10 computers. So N here is 10. N is 10. What is P? P is the probability of event of interest, or probability of success. Success is here the defective purchasing a defective computer is quote unquote success, which is not necessarily, as I said, is not inherently a good thing. It's the event that you're interested in, right? No one wants to purchase a defective computer and call it a success, right? So success and failure is a different concept here. It means success means the event that you are interested in. So here we are studying the defective computer, and that's why we call the defective computer as a success. Okay, so the probability of success for us here, P, is 2%, and it comes from here, right? 2%. So the question asks for finding the probability of having 2 defective computers, and using the formula for binomial distribution actually is easy to find it. So let me get rid of this, and we're gonna solve the problem. So this is the formula for finding the probability of the binomial distribution probability. In our example, the probability of having 2 is n factorial. N here is 10. So 10 factorial divided by x factorial. X here is 2, multiplied by n minus x factorial, which is 10 minus 2 factorial, and multiplied by the probability of success, or probability of finding purchasing defective computers, which here is 2%, multiply or power x. X here is 2, so that's power x, multiplied by the probability of 1 minus the probability of purchasing a defective computer, so that's 1 minus 2%, power n minus x. N here is 10 and x is 2, so power 10 minus 2. So if we do that, we're going to get 0.015. So that's the probability of purchasing 2 defective computers in this experiment. Another example. Bill is a sales representative in Northern California representing a line of athletic socks. Each day he makes 10 sales calls. The chance of making a sale on each call is thought to be 30%. What is the probability that Bill will make exactly 2 sales? So this is a binomial distribution example. Why? Because each time that Bill would make a call, he is either going to be successful, a sales call, or he's going to fail, right? So there are only 2 possibilities. So this seems to be suitable for a binomial distribution problem. If we define x as the number of sales calls that he makes, number of successful calls or sales calls, so number of successful sales, number of sales, then x would follow a binomial distribution. What is n and p here? N is the total number that the experiment is repeated here. So each time that he makes a call, how many calls he makes? He makes 10 calls. So n is 10. What is the probability of success? So each time that he makes a call, the probability that he gets a sale is 30%. So P is 30% or 0.3. So the question asks for the probability. What is the probability of getting exactly 2 sales? Meaning, what is the probability that x is equal to 2? So we just need to plug in the numbers here in the formula and get this probability. Probability of x equal 2, that's 10 factorial divided by 2 factorial multiplied by 10 minus 2 factorial. The probability of success or a sales is 30%. power x, x is the number that we want, which is 2, right? Multiply by 1 minus p, 1 minus 30% is 70%, power n minus x, n here is 10, and x is 2, so power 10 minus 2. And if we do that, we're gonna get 23%. So the probability that Bill would make exactly 2 calls is 23%. So why do you say exactly 2 calls? Because you say it's equal to 2. What if the question said what is the probability that Bill would make at least 2 sales calls? At least means that it's greater than or equal to 2, right? So that would be the probability that x is greater than or equal to 2. How would that work? It would be probability that x is exactly equal to 2 plus the probability that x is equal to 3 plus the probability that x is equal to 4 plus the probability x equal to 5, 6, 7, 8, 9, and 10. This would be at least. How about when it says at most 3 sales? At most 3 would be probability that he would make at most 3. So it would be x less than or equal to 3. How would we find that? It would be the probability that x is exactly equal to 3. So exactly equal to 3 plus the probability that x is equal to 2 plus the probability that x is equal to 1. So this would make the probability that at most